Welcome to PhET. This video primer will give you an introduction to the simulation features and uses. This overview is intended for teacher viewing only. Sims are designed to be exploratory tools, and showing this to students can interfere with their exploration of the simulation.
The Forces in Motion basic simulation consists of 4 screens. On the net force screen, students explore balanced and unbalanced forces. On the motion screen, students push an object to investigate force. The friction screen introduces frictional forces. And on the acceleration screen, students can explore Newton's second law. On the net force screen, students investigate balanced and unbalanced forces in a tug-of-war competition. Students can drag pullers up to the rope. As students add pullers to the ropes, arrows appear above the ropes to indicate the amount of force each team will exert on the cart. To start the tug-of-war competition, click Go. The winner is declared when the cart reaches one of the stoppers. Students can use the return button to move the cart and pullers back to their original positions. In my classroom, I challenge students to come up with a list of rules to predict which way the cart will move for any arrangement of pullers along the rope. I would then ask students to predict the winner for different scenarios. For example, I might place 2 small pullers on the red team and 1 medium puller on the blue team. Students might find that the sum of forces and values are helpful when making their rules and predictions. I may also ask my students to explain the difference between balanced and unbalanced forces and their effect on cart motion, using evidence from the simulation to support their ideas. Students can continue to investigate relationships between applied force and motion using the motion screen. The screen opens with a pusher standing next to a box on a skateboard. Additional items to place on the skateboard are shown below the track. Students can drag the pusher to the object to apply a force, or they can move the slider. But as soon as they let go, the pusher stops exerting a force on the object. A constant force can be applied on the object using the arrows on either side of the force readout. I may ask students to explain why the box remains in motion when the pusher lets go. I would then ask my students to predict what happens if the mass is changed while an object is in motion. On the friction screen, students can again exert a force on an object, but this time they can adjust the amount of friction between the object and the track. Students can also view the net force to help them make sense of the role friction plays in motion. On this screen, I begin by challenging students to determine what conditions must be met in order for the object to move. This could lead into a discussion about the friction force and the static and kinetic coefficients of friction. On this screen, students can determine the mass of a mystery object, qualitatively or quantitatively. In the model, all items have the same coefficient of kinetic friction, set by the friction slider. The acceleration screen adds an acceleration meter, which displays a precise value when values is checked. I would begin by asking students to explore the relationship between the acceleration and the speed. I would also challenge my students to investigate the relationship between net force, mass, and acceleration. Be sure to check out teacher-submitted activities on our website that can be used with the Forces in Motion Basics simulation.
You can find more resources for using this simulation on the simulation webpage. Teaching ideas and tips for using PhET can be found on our Teacher Resources page. Thank you for being a part of the PhET community. Find more information about PhET on one of our social media pages or by subscribing to our newsletter.